Good afternoon, everyone. We've made it to Wednesday, towards the end of the conference. I hope you've all enjoyed it. And I'm sure a few of you will be going on to the workshops as well. There's been some fantastic speakers, and I know I've really enjoyed some of the sessions. So one of the ones I wanted to kind of just mention was, did anybody go to Colin's talk about when all the things go wrong? Get a show of hands. Anyone? Yeah, excellent. I thought that was absolutely hilarious. Really, really enjoyed that. And I think it just gave us all a lot of things to kind of keep our heads up on and things to consider when we're going into our own projects. So before we start, we'd like to ask you a few more questions. Kenichi can start.
So show of hands, who's currently working with Monoliths? Oh, interesting.
Yeah,
and keep your hands up if you consider these monoliths as your legacy services.
Okay.
Cool.
So who's migrated from monoliths to microservices? Yeah, a few. Excellent. So who's using Kubernetes for those in production? Yeah.
And who's moving back to monolith? Ah, come on.
So I'm guessing the people who started with monoliths and don't consider them legacy, that was a choice. Anyone want to raise their hand and say, I chose to do a monolith? No, well, a couple. Excellent, good.
Cool.
Excellent.
So I guess this talk is all about where are we now. Microservices became mainstream. We are moving more and more to a decentralized architecture. Some of us are considering move to Kubernetes, already in there, like we've seen earlier. We as an industry has been talking about stories of growth. As you have heard earlier as well in the previous talks, we learned some lessons along the way. In this talk, we're going to talk more about the challenges we face transitioning in comparethemarket and how we solve those challenges.
So we're going to take you on a journey through several years of evolution at comparethemarket, discussing why we built our own platforms and how microservices facilitated growth at comparethemarket, and importantly, how we save our customers money. So firstly, brief introductions.
So this is Stewart. He's our principal solution architect. He's one of the key persons involved in building comparison as a service, which we will talk about later on.
And that's an attempt at a smile, by the way. Sorry about that. This is Kenichi. Kenichi is our cloud solution architect. He's responsible for our Kubernetes platform and all the great things around that. We won't dwell on that slide. So, Kenichi, who are comparethemarket?
That's an excellent question, Adam. Comparethemarket allows customers to compare prices on a number of insurance products, including car, home, van, pet, life, travel, and over 50s insurance. It has also expanded into comparison of items that can be switched, such as energy, utilities, broadbands, and digital TV, as well as a large range of financial products such as loans, credit cards, and ISAs. And recently, I've been trying to get some mortgage on it. In a nutshell, we are a price comparison website. We're aggregating quotes for all sorts of products, from insurance to finance.
Comparethemarket started life in 2006, just as the comparison and aggregation market was really starting to take off. During that time, I think everybody kind of just felt comparison was the same. There were other competitors. We all looked the same. We were delivering the same message. It was all about saving money on car insurance. So we really struggled to differentiate in the marketplace from those competitors. So then in 2009, kind of all of that changed really with the launch of the meerkats. And we've continued to grow consistently ever since then really. So just out of interest, how many people in the room have used comparethemarket for comparison services?
Wow.
Excellent. So quite a few of you, so you know who we are. Excellent. And for the rest of you, why not? So before we go any further, I just wanted to give you a little bit of a disclaimer. So Obviously, we're talking about a lot of history. It might not all be quite right. I may have got some things in the wrong order. Some of the things happened in parallel, and telling you a story through that journey, obviously, the sequencing might be slightly out. But the events depicted in this presentation are based on a true story. Artistic license has been taken. We believe that this presentation is true to the essence, values, and integrity of our story. So what do we want you to take away from our talk? So firstly, evolution over revolution. What do we mean by that? So we'll explore that in a bit more detail as we go through. But it's about continuing to deliver value to customers whilst we advance the architecture. Be brave. Things can and do go wrong. A number of talks have kind of touched on that theme as well. You need to be prepared for those things going wrong. But we shouldn't be afraid to make those changes. It takes bravery, but use all the information you have.
And lastly, platforms can help scale microservices. Having the ability to reuse multiple components while keeping them backwards compatible. And also collaborating with each other is key. We will touch a little bit about healthy competition, how that drives ideas forward while having consistent approach by doing collaboration. And of course, we're going to start this journey with our favorite, Monoliths.
Indeed. So, like most companies, we started with a monolith. We had a centralized IT department. We had specialized teams. We had silos of QAs and dev resource and service delivery who, took all these nice features, had no understanding of how they were built, and had to support them and bug fix them. It was all on-premise data centers, but it got us to market. It delivered value, and it saved our customers money. And I think that's kind of one of the messages that I'd like you to take away as well is there's a lot of technology out there. There's a lot of things that you can use. But the most important thing is delivering value to our customers and making sure that we do that as quickly as possible, obviously as safely as possible. Yeah. So we're done, right? We've delivered this. We're delivering value to customers. It's all working. What else do we need to do?
Yeah, it worked until...
So, compare the market started growing. As I said earlier, we hit 2009. The meerkats came in, and we saw a massive level of growth. Probably not quite the same as some of the other people you've heard, but it was significant. And as I say, it's kind of continued on that trajectory. So, it became apparent, really, that infrequent releases, this is a story I'm sure you're all familiar with. We were releasing them frequently. We had a single monolithic application. We're trying to serve all of these different products, whether it's home, car, life, out of this monolithic application. And it just wasn't sustainable.
Yeah, so the problem with the infrequent releases, so we started really with our evolution of the systems by working with people first, because we identified that monolithic application isn't really built in isolation. You build it with people and collaborating with people. By working with people first, by bringing business closer to tech and forming product teams, we were able to we're trying to solve some of the problems. So I guess the question is, once you have these teams, what is the aim? Or if you have multiple product teams, what are the aims of those product teams?
Yeah, I think it's quite a common practice now. How many people work in product teams? Anyone, everyone, lots of people. So I think that the days of kind of these siloed departments are mostly behind us, and we have a lot of, the trend is towards product teams and co-location, although moving more into remote-based working as well. But I think it's important just to kind of reflect a little bit on why we did that and why that kind of worked for us at the time. So it's really about that rate of change. It's about the innovation. We're releasing new products to market. We're working through, changes to those products. It was quite a new experience doing comparison. So there was a lot of change in those early days. It was about self-service. It was about delivering stability. It was about being close to the product owners. All the things that the Agile Manifesto tells you are good things, and as you go through all of that. We've done that to death probably at many conferences for a long time now. But I think it's important to kind of reflect on that, as I say. However, some products were still sharing the original monolith. So as we evolved, we had a core platform that was the monolith, and we started building UI monoliths off the top of that. So we were basically building front ends in a monolithic style on top of our monolith. Wonderful.
Monoliths after monoliths. So what did that look like for us? Oh, monoliths. Yeah. Stonehenge, we're in England, so monoliths. Now we have product teams building. We are building, running, and owning vertical slices representing each product. And then we were able to quickly add new products by just spinning up new teams, which is, I'm sure you're aware, is really good because you get new team, you get new product on the market. At least that's what I say. Again, this worked for Compare the Market. We were able to save even more money for the customers, which is the ultimate goal of Compare the Market as a company, to save customers some money. Product teams had the freedom to innovate and make changes as they see fit.
I can sense there's a but coming.
There is. We now have even more monoliths, a lot more monoliths.
That's okay though, right? I mean, we're meeting the customer's expectations.
Oh, not really. We're saving the money, all right. But now we've struggled to deliver more features across all products. And then we'll talk about that more later. But this is the key reason why our architecture started assembling Stonehenge, essentially. We started thinking about how we solve some of the problems that multiple monoliths brought. Having a single backend with multiple front ends seemed like a good idea at that time because we had single UI and single backend, and that's it. But there's like a lot of products. Of course, having the ability to write multiple front-end products, journeys, within a single backend did also create some problems because when you do something in our space, it creates trade-offs, right? Because everything is a trade-off in our industry. So I guess the question is, what were the advantages or disadvantages of this new approach?
Yeah, so one of the advantages we had with having moved to a product team organizational structure was it really gave us the ability to actually start experimenting with our architecture. We could start trying different things out on different products. Teams had complete control over their product, so they could streamline their processes and reduce the technical overhead of running multiple tiers. So we started seeing the collapsing of some of that. We were, to start with, we were very much a sort of N-tier application, but we started collapsing some of those tiers. We didn't need them. We could talk from the web front end straight to the database. Why not? It's much simpler. It's much easier. Why do we need service layers in between? So, at that point, we're talking about a world where .NET MVC was kind of fresh and new, and everybody's like, this is the technology choice.
MVC was really popular.
Yeah, I don't know how many of you are kind of .NET versus Java versus any other language, but we were very much a kind of Microsoft shop at that point in time. So we'd transitioned from VB.NET through to C#.NET, and so MVC was the natural choice. But we started to see challenges around how we thought about and acted on our data. So we've now got these monolithic applications that are talking to single databases, and what we were essentially doing was, like a lot of people, we were just putting all that data into our data warehouse. There was obviously ETLs, there was cubes, all of that kind of stuff. But we were going straight from the application space into our other requirements for that data. And that meant that whilst the teams had loads of control about how they could change and evolve their product, any changes to the schema became costly. They became expensive to understand, to reason about, and to make change in our cubes and our data warehousing infrastructure. So it was obviously, created a coupling that was difficult to understand and fix problems with.
So this data challenge led us to the next approach that we tried. We saw that distributing systems while keeping data centralized is inherently incompatible. You're trying to fit round puzzle into a square box, essentially.
So as we continued to grow, we knew that scalability would be a constraint. We could only scale vertically, and as you all know, that can be very costly when you run your own data center, the costs of bare metal, all of those things that go with it.
At this point, the technology landscape was exploding, right? Whilst the ideas were not queued, the technologies available had made this more accessible. We're talking about cloud, decentralized architectures, and the implementation of that. So there's a lot more technology. And then, so we started to experiment with this new technology, such as NoSQL data stores, CQRS, and event sourcing. Some speakers touched on that, command query responsibility segregation. I think that was the speaker that was this morning. So initially, within our data centers, we've done all of this and proved it. We proved the ideas would allow us to scale horizontally and solve the data problem. However,
yeah, so just to kind of set the scene as well a little bit, in terms of where we are timescale-wise, because I appreciate we've kind of run through quite quickly, this is now sort of the start of the cloud platforms. We're starting to see AWS starting to experiment with some stuff.
Yeah.
But we as a company weren't ready to go down that route. So we're still on data centers, but we know that we can't continue to scale in the way we are. So the initial experiments were largely successful, but it did come at a high cost. The more we try and scale, the more kit we need. We need VMs. We started virtualizing all of that infrastructure, but again, there's still a limit on how much you can actually do because you're constrained by the physical hardware. So as the various cloud offerings developed, this obviously presented an ideal opportunity. We can let somebody else worry about that hardware scaling, and we can just start using it as a commodity. So again, we kind of used those learnings on what we'd done in that space and how we embraced a more distributed architecture to kind of move that into the cloud. And that was kind of really our first foray into that environment. However, we still had the issue with data. We moved some of it, but we still essentially had all of this data that could change rapidly, and we were still trying to fit it into an old SQL data warehouse, and it just didn't quite fit. As we tried to evolve, you essentially make it backwards compatible by dropping some of the data. You're missing out on all the value then of doing that.
that was some sort of like addition by subtraction, wasn't it?
Absolutely, yeah. So we needed a way to capture events through the system, to share beyond integration at the database level. So this led to us implementing Kafka. Who's using Kafka? Anyone? Excellent. Yeah, that's another one of the everybody must use Kafka talks that happens at these conferences. And we were very early on to Kafka. So we started exploring that very early on in Kafka's kind of evolution, and I think it was still in beta at the time. And we could see how that could really help us to deal with this problem.
Yep.
So we started delivering business events through Kafka. So we talked earlier about we'd done CQRS, and we kind of got too granular with our events. They weren't useful from a business context. So it worked in the application space, it didn't work beyond that. So this now was a kind of attempt to rectify that issue, and we started generating more business events to send them through our Kafka stream. And that was very tightly controlled to start with. So at the time, the concept of microservices was still being formed, but we could start already to see how this kind of, parallel with our own architecture. So it was kind of a natural step then.
So the timestamp then would be like a couple of years back, because microservices was
2014, I'm going to hazard a guess. So
it's been quite a while. Right?
Actually, out of interest, Martin Fowler and James Lewis did write a paper which does reference us in that sort of time period, talking about the microservices. So if you're interested, go and have a look on Martin Fowler's site and you'll be able to read about that.
Yeah. So at that time, we were preparing to build a new customer proposition to reward customers for their loyalty. Because at this point, we have lots of customers, like lots. But our previous loyalty program was toys. But if you have lots and lots of customers that relied heavily on just toys, and obviously having lots of toys that relied heavily on the database integration, then we had to start to move away from this model and to build a newer system or a newer loyalty proposition that allowed us to keep more customers and attracting newer customers, which is essentially the point of what we're doing. So this presented us with an opportunity to make conscious decisions to implement a microservice architecture using learnings from previous evolutions of how many monoliths we built. So we became masters of monoliths, and then, doesn't work for us anymore because of this problem, which is, so let's start thinking about microservices.
Yeah, so this gave us a chance to really evaluate what tools, technologies, and processes we wanted to adopt. So taking advantage of containerization technologies, Docker. We targeted Unix and moved development to Node.js. As I said previously, we've been largely a Microsoft house, really. So we were using Windows, we were using the Microsoft languages. So having primarily developed in that, it was a great opportunity to try and explore that a bit further and use the right tools for the job. So, having already moved to at least daily releases,
Mostly.
we further streamlined the release process to remove blockers and move even closer to the ultimate aim that everyone talks about of continuous delivery. So, at that point, we started adopting a DevOps culture. And lots of people talk about the difference between DevOps culture and DevOps functions. And we're not going to go into too much detail about that. But essentially, the model was we had people within the team who were responsible for the DevOps aspects. And ideally, the whole team would have some element of knowledge around that.
Yeah. So one big change this introduced, or reintroduced, I might say, was the use of services provided by other teams. We kind of started touching about that earlier in the monolith world. But now when you have like lots and lots of small services, you need to do it better than when we did it before. So as we implemented our rewards proposition, we identified other services that will be built and owned by other teams, requiring a change in working practices to support this collaboration. At this time, also, we tried to find other approaches to ways of working, like mobbing and moving entire team to a war room. As you would have expected, some things work better than others. We found war rooms to be very good for the team initially, but it created a sense of isolation and hindered collaboration.
So, following the process of natural selection, the things that worked coalesced into what you might now recognize as a standard pattern for microservices architecture.
This diagram really is our first attempt to do microservices architecture, or what came out after that first attempt. So another first attempt at event sourcing that was too granular was leading hard to change. It's really hard to change, so we modified this approach to simplify with how events are raised, ergo the architecture.
Yeah, so lots of people have mentioned Conway's law, and that kind of definitely applied here. So continuing with the product team approach, allowed us to create the bounded context for the microservices, utilizing cloud-enabled, enabled an increase in speed to market and the flexibility to scale horizontally.
So yeah, we were able to remove database integration. That gave the teams freedom to innovate. Creating a proxy to handle events simplified the architecture, which is the HTTP proxy there that sends data to Kafka. This removes overhead for the team.
So competition versus collaboration. So we started thinking more about how we shape our culture for success based on the evolution to a microservice architecture. The two things go hand in hand. You can't just go straight to services and it all work. There is a definite cultural aspect to that. So product teams were great for creating a sense of competition. Each team wanted to outdo the other. They wanted to be better than the other team. So yeah, each team wanted to, be the first to take advantage of scalability that comes from a cloud-based microservice architecture.
So very early on, we realized that competition drives internal movements. The analysis by paralysis can easily be driven away by competition of different teams and different ideas to the marketplace of ideas. An iteration of new architectures and flow of new ideas, but too much competition, the keyword is too much, can lead to silos and lack of sharing, which is the same problem as we had when we did that war room. So we needed to find a way to allow for healthy competition whilst enabling collaboration so all teams benefit from our advances in collective knowledge. Through the use of forums, so we had some sort of forums and sharing sessions like brown bags. We continue to evolve our culture. So the knowledge is getting kept within the company and then being shared around using these avenues or mediums to foster a spirit of collaboration. So at the same time that the team were competing, they were also collaborating on sharing knowledge and collaborating in different aspects of the company. So building on this, we gain consensus. You can easily do a temp check where your engineering teams are going depending on what's being talked about in this forum, right? And this allows us to move quicker when adapting cross-cutting architectures. This means like massive changes that would have taken ages to be implemented. If you have this kind of forums and you have this consensus and this marketplace of ideas and then all this brown bag session, that allows you really to get that knowledge out really quickly. So by building the community of practices, we were able to bind these decisions and then use this to solve really complex problems in a very simple way. Complex problems, usually, they came about by microservice architectures, and this is our way of dealing with those complexity. We don't deal with complexity by trying to simplify stuff, but we deal with complexity by trying to understand it more deeply across the entire organization. So we don't look at it using one lens. We use all lenses within the organization to look at it.
Yeah. So as we started to collaborate more, it became apparent that we needed to focus on solving problems once rather than each individual team solving it. Seems obvious when you kind of put it like that, but at the time, it was very much a kind of product team, insular base. So which leads on to comparison as a service. So having decided that microservices would be the right approach, we needed to work out how to evolve from the rest of the monoliths. So we've still, we've done some trials, we've tried some stuff out. It all seems to work really well. So we started identifying the key responsibilities across all of those monoliths. We started looking at, what commonality is there between them. And so we set about identifying a pattern that could be shared by all teams. So to start with, we kind of go into this with, is it a pattern? Is it a set of services that everybody shares? So in the course of doing this, we realized that a number of the bounded contexts were rarely changed. And when they did, they had unclear ownership. So this allowed us to form a team around those core capability and create a set of microservices for consumption by those product teams. So enabled by the reuse of standard services, the product teams could focus on the aspect that they really cared about, building journeys and experimenting with improvements for customer experience. They also facilitated a consistent experience for developers and the data teams. So in order to allow the product teams to continue to evolve and innovate, it was vital that we offered other extensibility points, which is achieved through various handoffs to services owned by the teams themselves. And that's kind of what this diagram's depicting, really, is that, you know, we've got a kind of set of core capabilities over here, which are owned by the shared team, and then we've got some other capabilities which are essentially owned by the product teams.
Yeah, and as everything we've done, we didn't always get it right the first time. It took a couple of evolutions and iterations, but each provided value in building better experiences for customers and developers. This approach is already providing dividends for us. A good example of this is a recent regulatory change for ID, the Insurance Distribution Directive, which required functionality on many products. We delivered this in a quarter of the time on comparison as a service versus doing the same change on all of those product teams, still on the previous monolithic architectures. We have increased speed to market significantly with this new approach for new features and reduced the effort required to create new products.
So, Kenichi, how does PaaS kind of fit into all of this?
I'm glad you asked that question. PaaS, or Platform as a Service, we do not want our product domain experts to build logging, monitoring, infrastructure, security. At the same time, we wanted to balance this with the ability to innovate. So building a semi-opinionated PaaS model is our way to go. We want our product teams and domain experts to focus on building individual customer values that adds customer propositions.
We've been experimenting with running a PaaS for a number of years as a way to achieve this desired state. So, you know, even before Kubernetes, we kind of started talking about, you know, how do we build a PaaS? How do we take away this pain? So what really changed, and you know, how did we end up where we are today?
That's true. There were a number of systems that tried to deliver PaaS, some very successful, but for compare the market, the combination of containerization, microservices, and the emergence of orchestration technologies such as Kubernetes, Mesos, and then Docker Swarm, this all came together at exactly the same time when we needed them. And by the way, this is not just all about technology either. It requires a change in how the business thinks about software and the culture and working practices in place. Finally, we wanted to balance out the cost versus the rewards. By standardizing most of the underlying setup, like CI/CD, security, logging, monitoring, and infrastructure, we were able to standardize the cost. Standardized costs can be studied. They could be decreased eventually. This is also done to maximize developer productivity to increase overall customer reward or customer proposition output.
So why did we choose containers and specifically Kubernetes?
Yeah, so initially we chose containerization because it afforded us with the flexibility that comes with doing both .NET Framework, which is some of our stuff are still written in, and JavaScript in a single platform. So other languages were also available, but it kind of allowed us to use the right tools for the right job. We chose self-managed Kubernetes way back in 2016. We had started to move to AWS, and most of our fully managed services were still in their infancy. Ergo, a photo of a very young Adam there.
Yeah, quite clearly me.
Yeah, in fact, GKE was the first available full managed service at this point in time. However, moving to Google Cloud was not an option for us at that point.
Yeah, so we evaluated the choices available at the time. There was competing proof of concepts for Docker Swarm, Kubernetes, and Mesos. It was quickly apparent that Kubernetes fitted closer to what we wanted as a future state for the PaaS service.
Yeah, so one of the differentiating factor for us was the lifespan of the Kubernetes project, at least what we thought was the lifespan of the Kubernetes project. Our opinion was this would continue to be developed and supported based on its origin in Borg in Google, and it was initially built by ex-Googlers. And at this point in time, Google was adding more and more features to GKE, so we thought this would be the safest option.
And of course, as we all know, if it's good enough for Google, it must be good enough for us, right?
So we started to build platform as a service, and what better way to start with Puppet? But those are Muppets. I hear you say. It's quite close enough. It had all the functionality needed. However, the developer experience was lacking and innovation was stifled. This first version or first attempt of building PaaS was built in collaboration with other people. And during that time, Puppet was one of the most famous technology at that time. We spent a lot of time and effort building deployable platform as a service with some great features for the team running PaaS, but not so great for the people who are actually using the PaaS.
Yeah, this resulted in the exact opposite of what we kind of set out to achieve. We'd actually made life harder for our developers, and they spent more time on infrastructure issues than before on the PaaS. So we started to think about how we solved that problem. So after the puppet show failed, we got the cops involved. Sorry, bad pun. We started working on version 2, which was COPS-based. COPS is one of the most adopted Kubernetes installers in the market. It worked well to solve both differentiated customer problems as well as developer experience. However, it was still stifled innovation, as it had a single cluster per environment, and we had locked down the controls for governance reasons. So currently, we're exploring options to solve these problems and make the experience even better.
So following the feedback from version 1, we knew that observability would be a key area for us. And how it provided the insight, where we got the drop-off points for customers, for example, how we build a culture of like observability that's adopted by product teams using mostly interfaces and standards, which was presented during the keynote this morning. How we built those interfaces and built standardized libraries that produces standardized metrics. So we started adapting open source tech stack, for example, Prometheus and Grafana. Fortunately, it paid dividends because of the ease of integration with Kubernetes. It means that we were actually doing Grafana and Prometheus even before we went to Kubernetes. So, yeah.
So one question you might have on your mind, and I certainly do, is it worth managing your own cluster?
Definitely not. Unless you're, well, that's a caveat here. Unless you're running a full managed service, you're selling it. Unless you're Google, yes, or Amazon or Azure. Or, in our case, there's no available product in the market during that time. Or, if there's no product that satisfies your requirement.
Yeah. Basically, it depends. But go into it with your eyes open. We learned a lot through doing this. And I would say the key thing about building a platform like this is think about what your core capability is that you're trying to offer to market. Is it a Kubernetes platform? If it's not, that's probably not where you want to invest your time and resources in building that out yourself. There are other options on the market now.
Yeah. And, well, one of the main reasons why it's really hard shooting from the hip here is managing upgrades and life cycle of Kubernetes is hard. What I mean is like etcd, the database where Kubernetes relies on, has a lot of incompatibilities with regards to version of Kubernetes binary itself. It makes upgrade last quite a long time. However, yeah, as you've seen, like Kubernetes, there's always a new version of Kubernetes just right around the corner. So you need to keep up because there's new vulnerability fixes, security fixes, and stuff like that. But upgrading is quite hard when you're doing it full managed, self-managed. Full managed is so much easier.
Yeah, and as we've said a couple of times now, for a PaaS to be successful, it needs to provide a good developer experience. And we kind of learned that the hard way.
So we can't build a platform in one go. So we decided to evolve the platform based on a clear strategy. A very high-level strategy, but still quite a clear strategy for us. This can change over time, but having a line in the sand allows us to focus on the most important aspect or more urgent areas. This is key in prioritizing to build a successful delivery of a platform as a service.
Yeah, so essentially build your platform in stages, work collaboratively, and take the developers on the journey with you. Apply everything that you've learned in building systems to how you build platforms. The same rules kind of apply.
Yeah, but we also don't want the evolution to be restricted or constrained by knowing the end state of the platform. However, we also do not want to lose the sight of what we're trying to achieve. Simply, what does a complete platform look like for us in compare-the-market?
So finally, we want our developers to use our platforms as components and only focus on building differentiating systems that our customers will directly benefit from. We want to engage with the teams early and often.
So this ultimately means treating your platforms as products and your internal products. Treating your developer teams as your customers. So what we have here in this diagram really is we have building blocks for the developers to play around with. So they use the right technology or the right tool for the right job. But the only thing that your product teams need to be concerned about is what is the outcome. What does good look like? What does good look like for the end user, for the customers?
So, evolution, not revolution. Innovation and playfulness creates evolution. Revolution cuts at the roots. We're not trying to say you can't rewrite things, you can't change things, but be aware of what you're trying to do in that regard. So, you know, innovation and playfulness, and that will evolve your systems.
Yeah, and we need to acquire new information all the time. We need to try to get our currently held beliefs or the dissonant beliefs in order to cause dialogue. You need to have and explore these ideas with your teams and your communities of practices. And then you need to develop these ideas further. For example, in the words of F. Scott Fitzgerald, intelligence is the ability to hold two opposing ideas at the same time. And finally, when facts change your mind. It is this intelligence that gives us this ability to experiment and pivot our hypothesis based on new information provided. So you won't get stuck into, that's how it's always done. It's always been done. But at the same time, trying to balance that out with what is the need of your customers or your business.
So throughout this journey, what have we learned? So evolution. Grass isn't always greener. So there is a bit of a trend to kind of throw things away and start from scratch. It can leave you exposed when new requirements come along. So, you know, regulatory change, for example. So, you know, evolution. It's better to incrementally improve rather than get stuck making big changes, and frequently leads to better outcomes. Again, like I say, we're not talking at the level of, you know, a service where rewriting that service probably makes sense, but it's about evolving architectures, evolving cultures.
Yeah, the second one is be brave. Pivoting hypothesis based on your information is important. Do not be afraid to change course, especially if you know there is a better direction based on your information. Lastly, platforms. Your developers are also your customers. Use them to understand how to evolve your internal systems as well as customer-facing systems.
So hopefully you're getting the trends for evolution here. So yeah, kind of moving from legacy systems can be difficult. In fact, it can feel like it's never ending. And you know, each problem solved, you might find 10 more. So this can lead us towards that actually starting from scratch might be the better approach. See my previous comments about evolving. So there is another way, and that is to embrace that evolution. So by choosing the appropriate tools and technologies to complement your existing architecture, you can create your own evolutionary branch.
And finally, we would like to leave you with a praise attributed to Charles Darwin. It is not the strongest species that survived, nor the most intelligent. It is the one that is most adaptable to change. It's goodbye from me.
And it's goodbye from him.